Hi, I'm Daniel Smith, Southwest Regional Agronomist for the Nutrient and Pest Management Program at the University of Wisconsin-Madison and UW Extension, and today I'm going to talk to you about research and demonstration plots for producer-led watershed groups. So why does this matter? A demonstration plot may or may not be replicated. Results are often not repeatable and should not be used to base agronomic recommendations. These include strip trials, commercial variety demonstrations, etc. When we think about what a demonstration plot is, we think about farm technology days. This is a great way to see new equipment, new agronomic techniques out in the field being demonstrated. These can influence what we do on our own farm, but they should not be based to make agronomic recommendations. They can be a guideline of where to start, maybe some further research, and where to explore some new technology. We think about a demonstration plot as being useful if we collect some data and if we replicate it, though, however. So we can still have really valuable demonstration plots, but we just need replication in time and space to have a good trial that we can collect some really good data off of. Demonstration plots can also be useful to see how a new cover crop performs on our farm. They can be useful to see how a new strip till machine performs on our farm, how a new piece of harvesting equipment performs on our farm. But may not be best to make our agronomic recommendations off of. A research plot is replicated for statistical analysis. Results and treatments are repeatable. So when we do a research project, we can tell a farmer that we have done this over 4 applications, over 2 to 6 years even, and say, hey, every year we've gotten the same results. We're 95% sure that on your farm you'll get these same results. This provides data that's agronomic recommendations could be developed off of. And in the photo, you can see a small plot research trial being put out. We're looking at some soil amendments and different tillage treatments. And then the next photo is showing some of those yield differences off of a research trial that we can expect to see. And if we have replication then, and those same yield results are true across 4 replications over 2 years, then we can be really sure that these agronomic recommendations can be developed based on our research. If it's just simply a demonstration plot without replication, we have 1 replication of a strip throughout a field, still has value for some instances, but again, we really can't have that power to develop any sort of agronomic recommendation off of because it was just 1 spot and 1 time. We look at what research plots do for us, and they're answering questions with a repeatable result, and they're going to influence our future management decisions. We're going to be able to collect data, and they're designed for statistical analysis. So we look at economics and credibility. Research-based results can provide data to support and disclaim an agronomic practice and could have huge economic consequences. So in our example, farmer A wants to apply a soil amendment. A demonstrated plot showed a 6 bushel per acre increase. Research, however, has proven this practice is not recommended. The farmer spends $12 an acre. That's not necessary. And in the photo, you can see we're doing some of that soil amendment research and helping farmers make better decisions on their crop inputs. So you want to do some field research. What are some good steps? So we want an objective and a hypothesis. This is what you're testing and a tentative explanation of the research. We want to plan the experiment to test this hypothesis, and then we want to implement the plan. So errors and poor attention to detail can result in failed research and mixed results that are going to be very hard to interpret and probably have very little value. We want to collect data and interpret the results through statistics. So now that we've decided that we want to do some field research as part of our producer-led project, where should we look for some help? We want to look for collaborating agencies and local partners, nonprofits, innovative industry partners, extension. So our network of extension educators and extension specialists can provide some assistance and some technical details to help with field experimentation. And there's several really good publications. One highlighted here on the slide is the Technical Bulletin from SARE, describing how to conduct research on your farm or ranch. Always ask for some help with anything that you're unsure of when you're thinking about doing a research plot on your farm from these local partners, and this is particularly important for experimental design and data management. So I'm going to walk you through an example of a field research project that I've done, and our objective was to evaluate interseeded cover crops and interseeding's impact on corn yield. The hypothesis is red clover and winter rye will establish using interseeding techniques. I have a few treatments in my study. So I have a control treatment, so there's going to be just typical cropping practices done and no cover crops interseeded in this plot. I'm going to interseed winter rye in treatment number 2. Treatment number 3, I'm going to interseed red clover. Treatment number 4, I'm going to interseed radish. And finally, treatment number 5, I'm going to interseed oats and peas. This is my trial map. So I have my treatment list here, treatments 1 through 5, and I have my replications 1 through 4. So I'm replicating this over 4 different times in my field, and these plots could be 10 by 50 feet wide. They could be 30 feet by 300 feet wide. It's really variable depending on what size of field equipment you have, and we'll talk about that in a little bit. My first group here, my block number 1 is in a randomized order. You'll see that none of these are in the same order across blocks. And you'll also see they're not in the same order as what I presented in the previous slide. So this is a randomized complete block design where each plot is in a different location in each block, and the blocks are randomized as well over 4 replications. I want to match my plot size equipment to my plot size. So I have 10 by 50 foot plots in this particular example, so I'm going to use 4-row equipment. My interseeding drill is going to be able to easily interseed those 3 rows that are going to be my middle 2 then for yield. And I'm using a 4-row planter and a 2-row combine. Obviously this is small plot research. We're moving on to some large plot research, then we can start to think about 20 by 300 foot plots, and where we're using maybe some broadcasting equipment or some larger drill size equipment for drilled interseeding. And then I can combine these plots with traditionally sized combines and calibrated yield monitors, or a grain cart with a scale on it. I can also use maybe some portable scales or an elevator scale if I'm close to those areas that have that technology to harvest these plots and get accurate yield data. Maybe some things to think about though is how big your equipment actually is and how big your fields are. So if you have some very large equipment with some smaller fields, we want to be very realistic. Too large of plots is going to introduce a lot of variability. We think about how our soils change over our farm landscape. We think about how our topography changes over our farm landscape, and this could result in some murky results. So we want a very consistent field. We want consistent area with some consistent soil types. We also want consistent soil fertility management, unless we're evaluating a metric that would involve some of those characteristics. But we want to be mindful of our field size and our equipment size when we start to look at doing some field research. So we look at plot size and edge effects. So this photo is of a 4-row plot, and we can see here this middle row has a nice stand of cover crop, and our edge effects are introducing maybe some more competition from a different treatment and such, and maybe impacting our cover crop over here. Also remember that we only planted 3 rows of cover crop, so there's no cover crop on this side of the plot. This is why we only harvest the middle 2 rows, to avoid those edge effects of our plot. So we're going to come in and we're going to combine these 2 for our yield and for our moisture and test weight parameters, and collect the data for our cover crop biomass off that middle row as well. So we look at our yield data, and this is interesting. This is an actual trial results, and we're sampling every plot, and we're using uniform sampling, and we don't have any statistical significance across this trial. We look at our control here. In treatment number 1, our control averaged 229 bushels per acre. However, in rep number 1, we had 218 bushels per acre. Rep 2, we had 255. Rep 3, 193. And rep 4, 252. So obviously some variation in the field, some variation in our trial. We look at red clover, the same variation, 205, 258, 192, and 177. So this is why we do replications, because if we look at these 2, in rep 1, we can say, gosh, my control was 218 bushels, but my red clover yielded only 205. Well, that's just in one small area of that field with one small plot. When we think about doing replication, then we can start to average these to come up with actual numbers that tell us the full story, and we can start to run some statistics to tell us a little bit more in-depth story and produce those agronomic recommendations that we want. So if we look at our treatment means, we had 229 for our control, 208 for our red clover, 216 for our winter rye, 205 for oats, peas, and 195 for our radish yields. And when we extrapolate the data a little bit further, we see quite a bit of variability in that data, and that's why we don't see that significant difference. Is that large amount of variability is going to be tough to account for and tough to separate those means. So we talked a little bit about our data as a whole, but if we look at a few plots in selective, we compare these means at 229 for our control and 208 for our red clover to our highest yielding plots at 258 for red clover and 255 for our control to our lowest yielding plots of 195 and 177 respectively for our red clover and red and control plots. You see that amount of variability. That's why we're sampling every plot. That's why we're replicating over 4 times over multiple years to develop a really sound recommendation. Obviously, we would be much happier if we had this 258 yield plot compared to our 255 rather than our 193 and 177. But again, that's the power of replication. That's the power of statistics to tell us the full story. We look at corn grain yield for this trial over 3 years. It tells a little bit more of an interesting story. We start to look at yields across time, and we see that 2014 and 2015, for the most part, we have very consistent stands of cover crops except for our oats and peas. We had a little bit of a struggle with those germinating and surviving that corn canopy pressure. But our yields are not significantly different until we look at 2016. 2016 is where we had severe competition from our radish and red clover plots, and these resulted in significant differences from our treated and our non-treated plots. So think about digging into the data a little bit deeper. We can think about an economic analysis and a benefit analysis of some of this data. Obviously, the data over time would tell us that we have some variability out in these trials and that we should be careful with our management strategy moving forward if we're going to adopt some of these treatments that we showed in these field trials. Look at another metric of data that's commonly collected is cover crop biomass. So we're looking at these 3 cover crop seedings. We'd want to go out and we'd want to sample how much biomass was produced by these cover crops. That way we could say on average this is how much biomass we could expect from these cover crops in an interseeding system. So how do we do this? We typically sample in a quadrant pattern, maybe a foot by a foot, maybe a meter by a meter pattern, and then we dry that biomass and then we weigh it and we get a dry matter value back. We also usually take some heights. So we take the heights of this cover crop, how high is it in the fall, how high is it in the spring, how much biomass was produced in the spring versus the fall. And then we can even move into taking some digital photos of these plots and finding the percent cover. So there's several applications that can be used to calculate the percent cover of these plots. As shown on the slide, we had about 10% cover from our winter rye in this system. Finally, look at data management. So it's really important to have a system to store our data and then further analyze our data, because we may get questions about our data. Well, for treatment 1, what did you do versus treatment 3? Well, if we have all this written down, we can look up the seeding rates of treatment 1 versus 3. We can look up our soil fertility data. We can look up our yields over time. So really good data management is going to be really vital to having strong trials that out on your farm. So we should probably ask for some help with experimental design and data management. And then the next step would be diving into an economic analysis of some of these trials. I'd welcome questions and comments at the email and phone number on the screen. I'd also welcome you to reach out to your local extension educator and your collaborating agencies on your producer-led grant.